morning. I want to thank everybody for coming to this year's TLT conference. I hope that you've enjoyed the morning so far, and I know that you're in for a treat in just a few moments with our keynote speaker, Mark Frauenfelder, who I had the privilege of introducing this morning. Mark is an editor, writer, artist, designer, author, and maker. Of particular note, he is the founding editor of Boing Boing, Wired Online, and the Make magazine. I know I'm very excited about his talk this morning. I hope you are as well. And so without further ado, I'll turn it over to Mark.
Thank you. Hey everybody, thank you so much for inviting me to James Madison University. I'm really excited to be here and talk to you today. So I wanted to start by just talking a little bit about farmers from 1900 to 1970. And an interesting statistic, in 1900, 80% of Americans worked on farms. They either actually were farmers or they lived in rural areas where they worked on farms. And so farmers had to be, because they were away from urban centers, they had to be really innovative. And they made a lot of their own equipment, they repaired their own equipment. Typically farms had a workshop on there. They had to be very inventive and creative by necessity. They were makers by necessity. Today, only 2% of people work on farms. So I was interested in looking at farmers as makers and kind of seeing where that would lead. And I found this farming machinery catalog from the 19th century. And it's incredible. These are just a few pages from a catalog that is several hundred pages long, very thick, and tons of different things. I think you probably rebuild society after the zombie apocalypse with the stuff in this catalog. And so this is a guy named Hugo Gernsback. He is known as the father of science fiction for his magazine called Amazing Stories that he started in 1926. But he was a really smart guy, magazine publisher, and he realized that in these early days there were a lot of people who had these skills because they lived in these rural areas, and they like to make things with their hands at work, and they also like to do it in their free time. And he's kind of not only the father of science fiction, but I think he's kind of the father of making as a hobby. And you can see some of the other magazines that he created before Amazing Stories, something called the Electrical Experimenter, the Experimenter, all these kinds of things that were for people who wanted to make things on their own time. This is actually an early photo of Hugo in a lovely patterned chair, looking at the equivalent of a widescreen television set of the day. The little dot there is actually a cathode ray tube. I don't know what he's watching, but he's also got a remote control in his hand. Gernsback was also the inventor of Google Glass. Here he is in 1963. So I decided to take a closer look at these magazines that Hugo made. And the Electrical Experimenter, when you look at it, the actual articles from 1917 to 1918, this is like 100 years ago, are the kinds of things that you would find in Make magazine today, or online on places that show you how to make things. So some of the examples: wireless transmission of power, free electricity from the wind, radio-controlled model boat, electricity to prevent future fuel crises, utilizing burnt-out lamp bulbs. These are things that are very fresh. And it made me realize that this kind of making as a hands-on learning leisure activity is not new at all. And that was surprising to me, because I thought like modern making started with the World Wide Web, when people were able to share their projects, but it's not true at all. I started looking closer at some of these magazines, and here's one, let's see, I'm not sure when it's from, but it's probably from the 20s or 30s. And this guy has a parabolic microphone that he can use to capture sounds from a distance and listen to a bird chirping from a distance. And it reminded me of something that we did in Make magazine. Very similar. We had a project on how to make a parabolic microphone out of parts that you could get from a dollar store. So there's a small umbrella. You can see the paint roller is the handle, and a little cell phone earbud headset is the pickup for the microphone, and it works really well. $3. This is when radio hats were all the rage in this model showing off something with an antenna and some tubes and stuff. And it's kind of silly and fun and showing, kind of celebrating the joy of making. It's very similar to a project we had in Make magazine. This is kind of a synthesizer hard hat that's got the same kind of a vibe. This is from 1961. Once people started moving to more into the suburbs, they had more room to kind of roam around, and so go-karts were really popular at the time. I really like this one because it's an electric go-kart. Typically they were made from lawnmower engines, but this one has a battery and it has an electric motor in it. And it is, I mean, it's identical to the one that we had in Make magazine, down to the tires and the wheels. And I like the way that the guy is like more safe and less safe at the same time. Complete plans for building a suitcase-sized power cycle. Look at the size of that suitcase. They had to do that to like get away with that cover line, but still pretty cool little device. And it's similar to this one that we had in Make magazine. You can see that the motor in the back is a 36-volt battery power. It's a battery-powered drill, and the drill turns the wheel. This thing has an incredible torque on it. I was trying it out in the parking lot of Make magazine, and it would just like shoot right out from under me, and I would land on my butt. But it was tons of fun. Teaching her wireless. And you can tell he's really interested in teaching her Morse code. But the fact of the matter is that making is like a really great activity for couples and families and groups and stuff. And it really shouldn't be called do it yourself. It should be called do it together, because that's like the fun of making is really like getting together with other people and figuring things out and sharing your ideas, collaborating on projects and things like that. So making was kind of on the rise for a while, and it started to kind of drop off, and so I was interested in this drop off, and these magazine covers show an interesting kind of shift in the way that popular culture thought of do it yourself. So this is a 1973 issue of Popular Mechanics, and if you look at the cover lines, it's like all about doing things. It's all about hands-on stuff. So it's got like a complete car care guide, plans for making vacation homes, how to wire a yard light, how to silence squeaky floors, how to hang shelves. It's all about like you doing things, a complete car care guide. If you go to 2000, same magazine, you've got things that you really could not do. World's tallest building. No one's going to build the world's tallest building in their backyard. Fastest PC you can buy, not make, but buy. And then brain implants. Nobody's going to be doing brain implants at home, I hope. And Popular Science was, and still is, a very well-known magazine. And in 1970, it was, again, filled with do-it-yourself kind of stuff, things to make and modify, repair your own equipment. And then we've got Popular Science in 2000, and it's all about things that you can buy again. Revolution under the hood, looking at these cars. Matthew Crawford wrote a really great book called Shop Class as Soulcraft. And he talks about modern cars. He said, if you open up the hood of a modern car, the only thing you'll find under it is another hood. Things are locked off from people today. You don't have direct connection. You don't have like a control over your own environment like you used to. And so why did this happen? Here's an example I think that can explain, or at least it did to me, why we saw the shift in this kind of decline in making. In 1954, you could buy a 15-inch color television set, and it cost $1,175. And if you adjust that for inflation, that's almost $10,000 for this little 13 or 15-inch color television set. When a TV like that broke, because you had such a big investment in it, what you could do is you could actually remove the back panel. They had user serviceable parts inside the back of your television set. And I still remember my dad doing this. He would pull the tubes out of the TV and then go to the drugstore and use one of these tube testing machines that were pretty much ubiquitous. They were like all over the place in stores. And you could then plug, as you can see in the upper right there, you can plug the tube in, and a little meter would tell you whether or not the tube needed replacing. And then you could open up the cabinet of the tube tester, pick out the tube you needed, take it home, plug it in. You had kind of a little bit of control in that device. You had an investment in it and a sense of ownership. And I just love this little 1962 picture from a popular science magazine of this guy saying that if you want to remove a picture tube from your television set and take it in for repair, that you can put it in your front seat and put the seat belt on. And that explains why cars had seat belts in the 60s. I was always wondering about that. So let's move to 2016. A color television set costs $140. So if you adjusted it backwards, it would be $17. Basically, you could get 70 of these TVs for the same buying power someone in 1954 had. And so what happens when a TV like this breaks? And that's really like the only thing that you can do with it, because if you open it up, you'll find little tiny surface mount components that you can't remove. It's probably glued together in a lot of places rather than using screws or other easy to remove fasteners. And even if you did put it in your car and put a seatbelt on it and take it to a repair shop, the repair person would tell you that it would cost more to even just try to diagnose the problem than it would be to fix the TV. So because of this kind of idea, it became easier to buy a solution to your problems rather than come up with your own solution to a problem and do it yourself. So as a culture, we have become used to the idea of just paying for answers to all of our problems. And so making kind of withered away. But not all over the place. There's kind of like this subculture underground where DIY never went away. And Whole Earth Catalog is something that some of you probably have heard of. It came out in the late 60s. A guy named Stuart Brand in San Francisco put it out, and it was kind of like a manual for hippies and back to the landers and commune dwellers as a way to reboot civilization and grow your own food, build your own houses, raise animals, create furniture, do all that kind of stuff. It's an amazing book, and I think the ideas in it still resonate today, and it's greatly influential in the modern making movement. And then punk rock also, I think, was a huge influence on a lot of people. A lot of makers that I meet today are middle-aged punks, and they encourage their kids to be makers, and that's because the whole punk movement was about short-circuiting the music industry so that you could book your own tour, press your own records, make your own band posters, set up your own venues. It was a very do-it-yourself movement, and that bled over and led to the maker movement. And then I think the third one was the zine revolution that started in the 80s, where the advent of desktop publishing software and the ubiquitous corner Xerox shop made it possible for people to create zines that were very eclectic and very personal, based on their own interests. These are some zines from my own personal collection. They were really great. I remember one called The Optimistic Pessimist for Pez collectors, and another one called 8-Track Mind for people who are like 8-track tape enthusiasts. Very cool and very influential in the maker movement. So those kind of that subculture of making has made its way back into mainstream. And I think the internet was really responsible for that. It was people making things and sharing photos of what they made and their build notes and showing other people how to make things. And you can divide the modern making movement that started in 2000 into two phases. The first one is about sharing the things that you made with other people and the instructions for making them. But even more interesting, and I think and really revolutionary, was phase two that started around 2008, and that is these same makers are not only making cool things, but they're making tools and techniques and organizations that allow everybody to become makers of really amazing things that would have been impossible to do just a few years ago. And what they're really doing is they're bringing about the end of organizational advantage. And I'm sorry for the weird, like, I usually do Keynote, and I noticed this is PowerPoint, and it made that organizational, the L is dropped off, so I'm sorry about that, but you get the gist of it. What makers have done is they have taken all the different things that you would find in a large organization, like a consumer electronics company, for example. R&D, design, material sourcing, prototyping, all these things typically have a department in a large organization so that they can get a product to market. But DIYers have created inexpensive DIY versions of all of these departments as things that they can access online and kind of plug into and connect like Lego bricks so that they can make things either for themselves or for their communities, or actually try, if they were interested in doing that, to try to turn it into a product and sell it. So I wanted to dig into some of these DIY versions of things that typically you had to rely on an organization to provide. Research and development is something that has been very expensive. Now you can use the web as kind of a way to do R&D and figure out what other people are doing. I just did a quick Google search on remote control lawnmowers, and these were some of the first Google images that popped up. If 15 years ago, if you wanted to make your own remote control lawnmower, it would be hard to figure out how to do it. You'd have to reinvent the wheel because you would not have access to anyone else who did it. But you can go online and you can very quickly find the 1,000 people around the world who have built a remote control lawnmower. And not only that, you can get in touch with them, and it's really highly likely that they'll be very happy to tell you all about how they made it and share their plans with you and encourage you and give you all sorts of advice. It's an amazing resource. This is a really great example of people getting together to make something and actually beating industry to the punch. Espresso machines, especially, espresso machines for the last 100 years, ever since they've been invented, use a very simple bimetallic thermostat inside the boiler. And so what happens is the temperature inside the boiler can vary like 40 degrees Fahrenheit. And what that means is that the quality of the shot of espresso that you pull is really hard to nail it down, because with that kind of a temperature swing, the flavor of the coffee is going to be all over the place. You don't know where within that 40-degree range your boiler's at. And so on the alt.coffee Usenet group, some guy who was working at the National Institute of Standards and Technology borrowed from the federal government a special temperature controller system called a proportional integral derivative temperature controller. He brought it home and he attached it to his espresso machine, and he found out that he could lock the temperature down to about 0.1 degree Fahrenheit. So it's like 400 times more precise than the temperature control in a typical espresso machine. So he posted about it, and the whole Usenet group went crazy, and they're like, this is the most amazing thing in the world. How do you do it? And he told them how to do it, and people started buying these PID temperature control systems, and they started making kits. This is my espresso machine, and the little thing that's attached to the left with the kind of black cable snaking down is the PID temperature controller that I've added on there. And the interesting thing is that the espresso companies, the large manufacturers, never thought of doing this. They've always just had this bimetallic thermostat in there. And so it took them about 5 years to catch up, but now they finally have added PID to all of their espresso machines too. So this is like a great example of makers driving a movement. And so not only can makers use the internet to collaborate and research the things that they want to do, but industry can use makers as an R&D resource to improve their products as well. You have some interesting back and forth. And because of this, I think what you're seeing is like this sudden jump in the way that things are innovated, how quickly it's accelerating. And so everything you look at, from like drones to robotics to cigar box guitars, there are communities of practice. And because they're getting together for like the first time ever, they're able to see what they're doing, and they're just building on top of each other really quickly. So you're seeing improvements at a rate that is unprecedented. Makerspaces are a great R&D place too. I think I've talked about that a little bit. Just the fact that you get people together and cross-pollinate other people end up being like the killer app in the maker world. The most useful tool is collaboration. And there are, if you go to like hackerspaces.org, you can find all the different makerspaces all around the world. Design has become really inexpensive and really powerful. I started out as a mechanical engineer in the 80s in the disk drive industry. And when first year I was an engineer, we were using a drafting table and T-squares and pencils. And then the second year, we got some CAD software, and they were like these giant workstations, and we had these wireframe models that we were drawing on. And the software was like $10,000 per seat, and then they charged you by the hour. Once a month, some guy from the software company would come and plug some kind of a meter into the workstation, and it would spin out a little number saying how many hours we used it, and we would have to pay like $50 an hour for the amount of time we used on the system. Today you can get something like SketchUp and it costs nothing. And I'm not kidding, it's like 10,000 times more powerful than what I was using before. So having that kind of power at your hands to design things is really opening up design in the maker movement. And then having digital model libraries where people can take the designs that they made and upload them so that other people can modify them for their own purposes is a wonderful thing too. And that this kind of spirit of openness and sharing makes it possible to have all these different things that you can build on top of other people's creations. Materials is another thing that's, finding the right materials is another thing that's really important. Again, when I was an engineer, if I needed to find something like a bushing or a motor, I would have to go to the library at Memorex where I worked and get these catalogs that were typically out of date and just flip through these hundreds of pages of thin newsprint and try to find the right kind of motor with the right kind of specifications. It took a long time, took a lot of phone calls. Now it's so much easier. eBay is kind of like this indexed surplus store that has everything you need. I needed some light dependent resistors that change the value of the resistance depending on how much light hits them. So I found this 20 resistors for $2, and that is including the free shipping from China. So I received like this little hand wrapped box with stamps on it from China for $2 for these things. I have no idea how they can make a profit doing that, and that it's worth their time, but it's like a great way to get components. Alibaba.com, same thing. If you want something customized, this is a good place to go. A guy I know, Chris Anderson, who was the former editor-in-chief of Wired magazine, started a drone company, and he wanted to make a kit to sell drones, and he needed some motors, so he contacted a company through Alibaba for a custom-made motor with certain specifications, and they told him it will cost, if you want 100 motors, which is what he asked for, he said that it'll cost $1 per motor. But if you want 5,000 motors, it will cost you 17 cents a motor. So he went ahead and got 5,000 motors and ended up actually selling all 5,000 kits that he made. Excuse me. Prototyping is another huge area where things are taking off really quickly. When I was an engineer and I was making parts for a disk drive, like say the cover to fit onto the base plate, I would draw it up in 3D software, put it on a floppy disk, drive it across town to this guy who had a model shop. He would put the floppy into his computer, generate the tool path, tell me to come back in 2 weeks, and he would give me the milled out prototype. And I would take it, pick it up, bring it back, and invariably it wouldn't fit. The screw holes would be misaligned. It would be too big or too small. I would have to change it. The iterative process, each iteration would take a really long time to do. Now with things like 3D printers and CNC routers and laser cutters, you can do this thing in a matter of hours or minutes. And so having that kind of iterative cycle speed up is incredible, because you can make your mistakes, get your mistakes out of the way a lot more quickly and at a point where mistakes are less expensive than later on down the line. The Arduino, I'm sure that who has not heard of Arduino? Well, that's great. Almost everyone's heard of it. Okay, just quickly for those of you who haven't heard of it, it's like a credit card-sized circuit board that lets you add interactivity to your projects, and you don't have to be an electrical engineer to do it. It's really a very easy program that you can write what they call sketches, which are little programs that you configure the inputs and outputs of the Arduino device to make all sorts of things happen. And here's an example of somebody who did that, a guy who's not an engineer. His name's Michael Hart. He designed something called the reverse geocache puzzle box, and it's a box that only opens in one place on the planet. He made it and he gave it to someone as an anniversary gift, and he said, your present's inside, and they tried to open it, it wouldn't open. And so they saw there was a button on it. They pushed the button, and they saw something that said like 393, and then a space and 1/20. And they're like, what does this mean, Michael? And he said, well, take this and get in your car and drive a little while and then push the button again. So they drove for a while, and then they pressed the button and it said 397 2/20. And so after a while they figured it out. The first number was how many miles away they were from the place where the box could open. And the second was that they have used up 2 out of their 20 times to open the box. So they ended up getting to where they needed, and they popped open the box, and they got their present, and they also got a little peek at what was inside. There's not much in there. There's an Arduino, there's a little GPS unit to tell where it is. There's some batteries to power it, and then there's a little servo motor, the kind of thing that you would find in a model airplane that opens that pushes on the latch so that you can open the box. So imagine trying to make something like this before Arduino and before the internet had the ability to source these kinds of things. It would cost at least tens of thousands of dollars to come up with something like this. Now, this is probably less than $200, and this was like 5 years ago. You could probably get it for a lot less today. And so Michael, who's not an engineer, just kind of a creative artist person, was able to come up with something really cool and interesting, thanks to the second phase of the making world and the end of organizational advantage. This is something, I have 3 cats, rescue cats, and they love to jump on our furniture and then shed like crazy, and it drives me nuts. I have cat beds for them all over the place, and they want nothing to do with them. And so they love the couches. So this is one of those monkeys that smashes cymbals together, and then it's got a motion sensor in it. So as soon as the cat jumps on the couch, the monkey starts to screech and smash the cymbals together. And now I have like this, but I also just have some monkeys that are connected to anything, and they're just like cat scarecrows. It works really well. So this was something, I'm not an electrical engineer either, and I was able to, put this thing together in a couple of hours with a $10 motion sensor, and this monkey I think was $15 on Amazon. Very simple project to do and a lot of fun to make. This is so I read an article about some guy who applied for a patent to mix industrial chemicals in barrels where there was some component that was like a very solid, viscous kind of, almost a very, very like viscous liquid and a very light liquid. And by turning the barrels every 24 hours, it was a great way to mix it. And so I make a peanut butter sandwich for one of my kids almost every day for lunch. And I hate that natural peanut butter when you open it and you have to stir it. And it's like you're stirring cement at the bottom. And the oil is really light and it gets all over everything. And so this thing, all it does is every 24 hours, it just turns 180 degrees and turns the peanut butter. And it's an Arduino, and again, a very simple project, and it's a great way to Arduino is an amazing prototyping tool, because once it does what you want to do, you can replace that Arduino that costs about $25 with a little AVR chip, which just costs a couple of bucks. Raspberry Pi, I think most of you have probably heard about that. Again, it's a credit card size device. It's actually a complete Linux computer, and it costs about $30, and people are doing amazing things with it. They're making their own touchscreen tablets, home automation systems, cameras, and someone even made a working cell phone out of a Raspberry Pi. So being able to prototype very quickly means that you are going to make mistakes faster, which is what you want, because every time you iterate something, you're going to discover new problems with what you made. And so if you make those mistakes early on, you get them out of the way when you're just starting out. It's a lot less expensive. If you're an actual producer of something, if you find mistakes after you've designed your tooling and your manufacturing engineering has created the production line, that's super expensive. So get all those problems done early on, and I think it applies to industry as well as to like your kind of personal projects that you work on. Being able to make mistakes quickly is a luxury. And also mistakes can lead to good things too. I have this espresso maker, and you can see on the left that, well, I have another daughter, an 18-year-old daughter, who left my espresso maker on the burner and the handle melted off. So I said, okay, no problem. Well, first I was disgusted and I threw the whole thing in the trash. But then I realized, well, maybe I can make a handle for it. So I 3D printed that green handle and lid. And I said, oh, that looks so cool. It's going to be a great replacement. And I made coffee, and after about 30 seconds, the handle melted off. And I realized that was really dumb of me to use like plastic for a handle on something that gets hot. But the fact that I made that mistake, like in desperation, I looked around and I had like a small cutting board and a set of 3 and the little one that I didn't use much. And so I just cut out a wooden handle and a wooden lid for it. And it's worked now for about 3 or 4 months perfectly. And I think it actually looks a lot better than the green plastic handle. And so that's happened a lot to me, and I think probably to you, where you are doing something and you make a mistake, and then it takes you on a tangent in a different direction that you never would have done before had you not made that mistake. So you have to kind of look at mistakes as opportunities to do something in a different way that surprises yourself, which is really fun. Then another thing is funding. Typically a large company has its own sources of funding, or they can raise capital. They have connections with finance industry so that they can fund the things that they're making. That was really hard for makers to do. If they wanted to make something, they either had to do it out of their own pocket or hit up their friends or something. So crowdfunding, Indiegogo, Kickstarter, GoFundMe, those kinds of things give makers a chance to get the kind of funding that large companies are for their projects, but scaled down to what they need. So these guys who made a little iPhone tripod mount, they were looking for $10,000. People liked the idea so much they ended up getting $137,000. And so it's a great way also to like test out the viability of something that you make and see if people really like it. If they don't like it and it doesn't get funded, then you don't have to make you end up not making it, which is kind of a good thing, because it means that it wasn't going to succeed anyway. And then sales and distribution, thanks to the internet and how easy it is to put a store online and using social media to publicize what you have, you can sell your products. Before, you had to either start up your own brick and mortar store or have a special relationship with Walmart or Target or something like that to sell something. Now you just put it online. I did an Arduino workshop a couple of years ago, and when I was doing it, the woman who ran the makerspace said, before you get started, you should share your plans with this guy named Quinn. He'll look at your plans for you. He'll be your assistant at the workshop. I said, okay, great. So I sent him my Arduino schematics and sketches, and he wrote back and had all sorts of suggestions for improving them. I'm like, this Quinn is a smart guy. I said, I'm looking forward to meeting you. And I expected he was like going to be a college student or something. And when I got there, it was this guy, he was 12 years old. And I'm like, wow, hey Quinn, how you doing? And not only that, but he also has a company called Q Techno, and he sells products that attach to Arduino. And he does this all himself. I talked to his parents. His parents are both pediatricians, and they're like, we have no idea what Quinn is doing. The only way, like if you went to a store, the only way you could tell that it was being run by a 12-year-old is by the description of the product in the lower right-hand corner. It's a fart sensor. So then these phase 2 creations, you can see like, these are things that are made by ordinary people who just had a passionate idea, and they pursued it. And you can see that they look like things that you would see from a company like Sony or Apple or something. Very sophisticated looking things, and they used this end of organizational advantage type system to create these, and then by plugging into these networks and stuff. Here's a few quick creations that people have made. A remote control cockroach that you can steer around with like a model airplane controller, kind of creepy. This is something that someone made for people who have lost their vision. Those are distance sensors, and then it has cell phone vibrators in it, and you can hold your hand out and it will thump as you approach something that's in your way. This is something he threw together in a weekend, and it costs under $100. Again, just think of how hard it would have been to design something like this 15 years ago. Open source vehicles makes this chassis and motor and basic system for vehicles, for electric vehicles, and then you can buy these and then modify them and put different kinds of shells on them so that you can make trucks or taxis or different kinds of vehicles for different purposes. Imagine being able to have your own electric vehicle company without having all that infrastructure needed to typically make something like that. This is a really cool thing that people in Japan and Los Angeles, a couple of makerspaces, got together and collaborated to make a radiation detector after the Fukushima meltdown in Japan, and the Japanese government was not able to provide accurate and timely radiation readings and give them to the public. So these hackerspaces got together and made several hundred of these devices and gave them to people and told them to put them outside their car in a little pouch. And when they drove around, it would take readings of the radiation level and report back to a website so that they could build this map. They have 10,000 radiation data points that they've collected, and you can see the hot spots where the radiation is. And this data is now being used by scientists all over the world. Imagine if the Japanese government wanted to do a program like this, how much money it would have taken, the dealing with contractors, how much arguing, all that. And this is just a couple of hackerspaces, and they've created something now that scientists all over the world are using, and that now they're doing other kinds of environmental reading as well. So I've showed you all this high-tech stuff, but I always like to remember Scott Weaver, this guy that I met once at Maker Faire. And this is a picture of his entire tool and material set. There's like a razor blade, Elmer's glue, and toothpicks, and that's all he has, nothing else. And he makes things that look like this with it. And he had like 6 of these giant things. These are huge. This is a 3D model of San Francisco. And it's got little marble trails too. So you can drop a marble in Coit Tower there on the left, and it will just start winding and take a little tour through San Francisco and roll down and land at the bottom. You can see how little the marbles are at the bottom to give you an idea of how massive this thing is. So when I looked at all of this stuff, and I'm like, Scott, I really want to take your picture, and so I can show people who you are, because I think what you do is wonderful. He's like, all right, but first let me put on my costume. And there he is. So yeah, he symbolizes what making's all about. It's like your passion, and it doesn't matter like if it's high tech or not. It's just pursuing something that you love and seeing how far you can go, and constantly raising the bar and challenging yourself. So you're kind of in that flow state where something's not too boring that you lose interest, or not too difficult that you become discouraged, but always raising your own personal bar. So thanks, that's it. And I would be happy to answer questions and watch you throw that cube around. There's the ball, so just hold your hand out if you want it. Good catch.
Then,
Hi.
can you speak a little bit about how the maker community is reconciling the scale of cost? Because like you talked about those resistors being very cheap and then how could you make a profit? But we know that there's a hidden cost with cheap materials that we're getting, especially from overseas, in terms of labor distribution and mining of materials for processors. So how does the maker community reconcile the cheap currency cost with a potential high environmental and social labor costs?
Yeah. I don't think they're doing a really very good job about it, actually. There are some makers that are concerned with that, but I mean, a lot of people, a lot of makers, especially makers who are trying to scale up and sell things. I mean, it's very popular to go to Shenzhen, and there are several books and guides and companies that will get you acquainted with manufacturing in Shenzhen and components manufacturing and things like that. So I think that remains to be an area that should be looked at and see what can be done in that area. And I agree with you that, you know, I mean, $2 for those resistors, including shipping and stuff like that, there are costs there that are being paid by other people for sure. Anybody else?
Hello.
Hey.
So despite popular mechanics and popular science, it seems like DIY is more robust than ever, and self-education is more robust than ever as well. And I'd like to hear some of your thoughts on what's the role of teachers in this super DIY society we live in today.
I think that teachers should be walking the walk and enjoying making just as much as the people that they're teaching, and that they should consider themselves team members and managers rather than traditional teaching, and that the emphasis should be on learning by doing rather than, you know, a lot of time spent learning before you're allowed to do anything. Do you want me to? Do you have any follow-up?
Well, there's learning by doing, but there are some concepts in schools that you might not do, but need to be taught.
Mm-hmm. Yeah, I think that's true. You have to find a balance for sure. But I think especially in the world of making, letting people like get a feel for things and just like grabbing tools after they have, you know, proper safety instructions on them is a great way to start realizing what the potential is, so that will spark ideas of what they can do with it. And so I think just jumping in as soon as possible is always a good thing to do, and that you'll learn a ton by doing that. And then you will have questions, and then there will be opportunities for you know, more traditional teaching and learning. Once people get a little bit of familiarity, then they are going to become naturally curious and have questions.
I found your story for how we got to where we are to be fascinating, and I was wondering if you could put on your prognostication hat and maybe try and tell us where we're going to go from here.
I think one of the interesting areas that makers have not yet had much access to, but will start to have more access to, is adding artificial intelligence to their projects. And that's because networking of devices is getting really inexpensive now. There's things like the particle, which is a little Arduino compatible chip that has a cell phone service plan built into it, in a very inexpensive one that's like $3 a month. So you could practically put somewhere this whatever you make anywhere on the planet, and having send data back and forth and access internet services. And so companies like Google and Amazon are offering AI basically on tap, kind of the way, you know, electricity is power on tap. Amazon, Google, other companies are offering artificial intelligence on tap. So when you have things like deep learning and machine vision and things like that added to your projects, you're going to see pretty amazing things. So I think AI is probably the thing that excites me the most that's going to be coming soon. Okay, I think that's it. All right, well, thanks, everybody.